All right, and this is the 2020 10B, problem number 16, which was also the 12B, problem 14. Bella, maybe it's Bella, I don't know. Bella and Jen play the following game on the closed interval 0 to n. If you don't know interval notation, I'm not going to unpack the whole thing here. There's many videos explaining it. Probably Khan Academy has one. The basics are that the brackets mean you include the endpoints, so 0 and n included, and parentheses in place of them would mean you don't include the endpoints. It's not an ordered pair. Of the real number line where n is a fixed integer greater than 4, so n greater than 4, they take turns playing with Bella going first. At his first turn, Bella chooses any real number in the interval 0 to n. Thereafter, the player whose turn it is chooses a real number that is more than 1 unit away from all numbers previously chosen by either player. A player unable to choose such a number loses. Using optimal strategy, which player will win the game? There's various options over here. Let's just try something out. To be honest, under test conditions, I don't think I would have got this. It took me a little while to get it. I probably would have had to skip it, maybe come back at the end. I don't really know for sure. I was able to get it later. Start with n equals 5, because it has to be an integer greater than 4. So now you have this interval from 0 to 5. Okay, now Bella's going to go first. What would be the optimal strategy? We don't really know. Try doing some trial and error, see what happens. Let's say, whatever, it doesn't really matter. Bella chooses, 4.9. Then Jen goes and she chooses, 3.89, because that's more than 1 unit away from 4.9. Then Bella goes and she would choose, let's say, 1.5. Then Jen's going to go and she chooses, there's still a gap between 0 and 0.5. Jen can choose something in there. There's also a gap from 2.5 to 2.89 that exists. So Bella can just choose 2.6 and then Bella will win. Is this optimal? Probably not, but just kind of do something to get an idea for what's happening, how the game mechanics work. This is where you kind of have to have an epiphany, and it has to come across. I don't know how you think of it. You just kind of think of it on the spot, but eventually you might try something like, what if Bella chose the midpoint, right? What if Bella chose a midpoint? If Bella chose a midpoint, it would leave 2 intervals for Jen to choose in. 0 to 1.5 not inclusive, or 3.5 not inclusive to 5. Now, Jenna's going to have to pick a number in one of these intervals. If she picks a number that eliminates this interval, like say she picks the midpoint, 0.75, then nobody else can pick in this interval anymore, because if she chooses 0.75, you can't choose 1.75 or 1.76 because it's more than 1 away from here, but less than 1 away from here, and you can't choose 0 because it's not more than 1 away. Now, Jen could choose a different strategy as well. We'll get to that in a second. If Jen does this and blocks out this interval, then Bella does the same thing in the other interval, choosing 4.25 or something similar. Okay, so what if Jen didn't block the interval, though? What if she chose 1.49, right? If she does that, now there's still 0 to 0.49 not inclusive that Bella can pick on for that interval. Okay, you might think, well, maybe Bella should choose something in that interval then. If she does, Jen can block the other interval and win. So Bella's not a good idea to choose something here. Instead, what if Bella chooses the exact same value that would be the equivalent value on the other side? So if she chose 1.49, just 0.1 below, 0.01 below this, she can choose 3.6 or 5.1, something like that, that is past 3.5. Now, this is going to have an interval left of 4.5125. So again, there's still two intervals, but now it doesn't matter what you choose. Once you choose, it ends the interval. So whatever Jen's going to pick, Bella takes the other interval, and then Jen can't choose, and Bella wins. So what we notice is that when Bella chose the midpoint, she won this game with the 5. Now, she won this one too, but we don't know if it was an optimal strategy. Why does this kind of seem to work? Well, think about it. There's always going to be two intervals. If you let n equal 6, Bella can choose 3, the midpoint. That's going to create two intervals from 0 to 2 point, or we could say 3, I guess, not inclusive, 2 actually. And then, or it's going to be from 4 not inclusive to 6 inclusive. Okay, so now think about this. If Bella chose 3, there's two intervals. If Jen has a choice in this interval, Bella has a matching choice in the other interval available. If Jen has no move over here, then she won't have a move over here. So as long as Bella does exactly what Jen does in the other interval created, if Jen leaves space like she did here for the second option, where Jen chose 1.49, leaving an open interval of 0 to 0.49, if she does that, Bella can do the same thing, so there will always be two choices left, one on the left and one on the right, at least two, right? Now, if Jen chose the blocker strategy, like we said, of 0.75 to eliminate this interval, then Bella eliminates the other interval and just consistently mirrors whatever Jen does. In this way, Bella will always win, and the answer is A. All right, and this is the 2020 10B problem 17. There are 10 people standing equally spaced around a circle. Each person knows exactly 3 of the other 9 people. The 2 people standing next to her or him, as well as the person directly across the circle. Before we kind of progress, let's just kind of, make sense of this somehow. Let's make a circle. We'll just number them 1 through 10. So 2, 3, 4, 5, 6, and then that's got 4 here. There'll be 4 over here. 7, 8, 9, and 10. Okay. So the 2 people staying next. So 1 knows 10, 2, and 6, right? 1 knows 10, 2, 6. Okay. Let's go on. How many ways are there for the 10 people to split up into 5 pairs so that the members of each pair know each other? We should probably suspect some kind of casework here. The trick is, how do we know which, type of casework to do? We could do like how many left pairs there are, or how many people are paired with the person to their right. But I think what I'm going to go with is how many people are paired across from each other. Okay? So we'll call them cross pairs. Let's say that there are 0 cross pairs. This would be case 1. So 1 is not paired with 6, 2 is not with 7, 3 is not with 8 or anything. In this situation, 1 can only go to 2 or 10. And if 1 goes with 2, 3 will have to go with 4, 5 will have to go with 6, 7 with 8, and 9 with 10. So it kind of falls like a domino. So there's one way if 1 goes to his right to pair up, and one way if 1 goes to his 10 to pair up. There are 2 ways under that case. Let's go to case 2, 1 cross pair. Okay? So if I erase this 2 crossed out, and I've got 6 crossed out. 1 just pairs with 6, right? How many choices do I have for the 1 cross pair? I've got 5 choices, right? Now, after I've made that 1 cross pair, since 2 cannot go with 7, 3 with 8, 4 with 9, or 5 with 10, I can pair 2 with 3, 3 with 4, or 4 with 5. But if I pair 3 with 4, 2 has no one to pair with because we're not doing another cross pair. So we don't want to do 3 with 4, but we can do 2 with 3, and that automatically means 4 is going to go with 5. The same thing happens over here, 7 with 8 and 9 with 10. So once you've made your cross pair choice, all the other ways are forced. All the other pairings are forced. So this one actually has 5 total ways for it to occur based on the 5 choices you can make for one cross pair. What about 2 cross pairs? Let's again start with 1 and 6 as the first cross pair. If I pair 2 with 7, you'll have 3 people in a row that cannot cross pair, and if 3 goes with 4, 5's not paired up. So I can't do 2 with 7. If I do 3 with 8, 2 is going to be stuck with no one to pair up with. And the other mirror image of 3 is 4, then 5 will have no one to pair up with, and similarly 5 is the mirror image of 2. So there actually is 0 ways for this to take place. Let's do case 4. What if there are 3 cross pairs? So if there's 3 cross pairs, again, if I do like 2 with 7 and 4 with 9, you're going to have 3 and 5 stuck. So I can't have 2 separate ones, right? Automatically, when I pair up one choice here, again, the first choice, 1 with 6, there'll be 4 people in between those 2 on the right. And I'm going to have to take 2 of those people to cross pair with 2 of them over here to make 3 total cross pairs. So I have to pick 2 of these numbers if 1 and 6 is one of the 5 cross pairs. Okay, so after I've made the 1 and 6 choice, if I take 2 and 3 both, right, 2 and 3 with 8 and 7, this works because now 4 can pair with 5 and 10 can pair with 9. I can't do 3 and 4 both because 2 and 5 will be stuck. I can do 4 and 5 both, crossing over with 10 and 9, and 3 and 2 both will be paired together along with 7 and 8 paired together. Right now, 2's with 7 and 3's with 8 to get our 3 cross pairs. So for this one, you're going to have 5 choices for the first cross pair. No, that won't work. What we actually have to have is 3 in a row. So 1 paired with 6, 2 with 7, 3 with 8. There has to be 3 in a row for this one to work. How many ways can I do 3 in a row? I can do 1, 2, and 3, 2, 3, and 4, 3, 4, and 5, 4, 5, and 6, and 5, 6, and 7. Make sure you go 6, 7, and 8. This is actually 1, 2, and 3. 1, 2, and 3 pairs with 6, 7, and 8. So it's the same one. Don't accidentally count twice. So we don't want those. There's 5 ways for us to have 3 cross pairs. Okay, next up we're going to go to case 5, 4 cross pairs. If you have 4 cross pairs, it should be really obvious you're going to have 2 people across from each other. They're not going to be next to each other, right? 4 with 9. Then 5 and 10 are stuck. They can't pair up, and it doesn't work. So it should be really clear there are 0 ways for that to occur. And finally, case 6, if I have all 5 cross pairs, there's only one way to do that. So you get one way, and you're going to get 2 plus 5 plus 5 plus 1, which is 13. Answer choice C. All right, and this is the 2020 AMC 10B problem 18, which was also the 12B problem 16. An urn contains 1 red ball and 1 blue ball. A box of extra red and blue balls lies nearby. George performs the following operation 4 times. He draws a ball from the urn at random and then takes a ball of the same color from the box and returns those 2 matching balls to the urn. So for example, after 1 turn, he could draw red, and then he would take an extra red ball and put it and the original back in the urn. It would look like this, okay? After the 4 iterations, the urn contains 6 balls. What is the probability that the urn contains 3 balls of each color? What we have to think about is in order for it to contain 3 balls of each color, he's going to have to select a red ball twice and a blue ball twice. And if he does that, he will have added 2 red back to the original and 2 blue back to the original. So we can think, for example, if he chose on his first draw red, second draw red, third draw blue, fourth draw blue, it will now have 3 of each color. Okay? So let's see what that would look like actually. If the first one he drew red, it would look like this after 1 draw. After his second draw, he gets red again. He would now have red, 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 blue. On his third draw, he's going to get a blue, so he will have red, 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 blue, blue. And after the fourth draw, he gets blue again on the fourth draw. He'll now take that blue out, get another one, add it back in, and he'll now have the required 3 of each kind. Okay, so the question is, let's first off do how many arrangements of RRBB there are. We can simply move the B over, RB, RB, and then we can put this B in the middle to get R, B, B, R. Those are all the ways that start with R. Then you can stand to reason that there's going to be a mirror image of these. We can write them or not write them. I'll write them for the sake of the video. If I start with B, B, R, R, it's like this one. If I do B, R, B, R, it's like this one. And BRRB would be here. The chance of these happening, though, is equivalent to the chance of these happening, because it's just a mirror image scenario by symmetry. So we can just calculate these probabilities and double it to get these ones, the number of ways it can happen. So what is the chance that he gets red on this first draw here? Well, it's 1 out of 2. Now, once he's in this position, what's the chance he gets red now? It will be 2 out of 3, because there's 2 red and 1 blue. Now, though, when he goes for the blue ball, because you have to draw blue to end up here, this is after the draw, right? There's a 1 in 4 chance only that he gets blue, and then on the next one, from this position, he's now got 2 blue and 3 red, which is a 2 in 5 chance. So we can simply cancel the 2, and the 4, and 2 times 3 times 5 is 30. There's a 1 in 30 chance of going RRBB. Now, let's go ahead and try the next one, and let's just kind of bash it out. It won't take that long. There's only a couple cases to do. So again, R is going to start off 1 and 2. But once you're in this position, which this one also has after the first move, you're now going to draw blue for the second draw, which is 1 out of 3. Now think about what it will look like. It will look like RRBB, because you've drawn 1 red and 1 blue. Now your chance of getting red is again 1 over 2. We'll add a red ball to the mix, and the chance of getting blue is the same as this situation, 2 out of 5. Again, cancel the 2's. 2 times 3 times 5 is 30. We probably should strongly suspect the last one's going to come out 1 out of 30 as well. Let's just verify. You don't want to ever assume things like that. So red's going to be 1 and 2. Blue's going to be 2 out of 3. No, 1 out of 3. Sorry, same as this one. So we're here. We just made the first 2 choices. After the first choice, it was RRB. On the second choice, it's now 1 out of 3 chance to get blue. Then if I get the blue, there will now be RRBB, but instead of getting an R, I now take a B, which will be 1/2, same as R was, incidentally. And then there will be 3 blue and 2 red, so I can see it's going to be, the chance to get an R is 2/5. It's just like this one, actually. You get another 1 out of 30. These are going to be equivalent, so there's a total of 6 out of 30, which is B, 1/5. All right, this is the 2020 AMC 10B, problem number 19. In a certain card game, a player is dealt a hand of 10 cards from a deck of 52 different cards. The number of distinct, that's different, unordered, that doesn't matter, the order doesn't matter, hands that can be dealt to the player can be written as this expression. What is the digit A? There were some earlier problems that maybe took a long time, but this one actually isn't that bad. So this is why you skip earlier problems sometimes to get to problems like these, which can be pretty trivial if you can think of a good tactic. So for beginning, it's combinations because the order doesn't matter. So do 52 choose 10 and proceed to set up the calculation. 52 factorial over 42 factorial 10 factorial. And then just write it out. 52, 51, 50, 49, 48, 47, 46, 45, 44, 43. Now we can write 42 factorial if you want for a second, but you're really just going to cancel it with this 42 factorial, so I don't bother. We've got 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2. And just make as many cancellations as you can. Just get the numbers up here. So we've got 10 and 5 makes 50. We've got 8 and 6 makes 48. You can put 9 into 45 5 times. You can put 7 into 49 7 times. You can put 4 into 44 11 times. You've got a 3 and a 2 left. There's nothing up here divisible by 6, but 3 can go into 51 17 times, and 2 into 46 23 times. Write what you have left. 52 times 17 times 7 times 47 times 23 times 5 times 11 times 43. Okay. Now, we don't want to multiply this to get that. That would take too long. So there must be some kind of time-saving technique we can use. In fact, there are many. You'll probably find at least 10 different solutions to this problem on the forums later on. So what I'm going to do, though, is observe that this number up here is divisible by 10. And if I divide it by 10, it's going to be something that ends in A, which is the units digit of the resulting number. So if we can simply divide this number by 10, take out a factor of 5 and a factor of 2, leaving 26, the units digit of what remains will be A. So we're just going to keep a running tabulation of the units digit. When I do 26 times 17, only 6 times 7 affects the units digit. So 6 times 7 is going to end in 2 because it's 42. 2 times 7 is going to end in 4 because it's 14. 4 times 7 again is going to end in 8 because it's 28. 8 times 3 is going to be 24, ending in 4. 4 times 11, or 1 at the end, is going to also end in 4. And 4 times 3 is going to end in 2, which means the answer is A, 2. Okay, and now for the 2020-10B problem number 20. Let B be a right rectangular prism, fancy word for box, with edge lengths 1, 3, and 4, together with its interior. For real R greater than or equal to 0, let S of R be the set of points in three-dimensional space that lie within a distance R of some point in B. The volume of S of R can be expressed as this expression, where A, B, C, and D are positive real numbers. What is BC over AD? Kind of hard to know how to start. Don't think too much about it. Just start making the box. So you've got 4 here and 3 here, let's say. We're coming over this way. And we're going to come up 1 unit, 1 unit, 1 unit, and 1 unit. And then we're going to connect over this way, over this way, over this way, and over this way. And this will be the 4, 3, and 1. Okay. It stands to reason that any point in the box will be R units from some point in the box. So we're going to include the entire box's volume as a potential place for the region S of R, the set of points. So 4 times 3 times 1, which is the volume of the box, is 12. Okay, from there, we're going to have to move R units away from each edge. So let's start going this way, R units. I would also go this way, R units, this way, and this way, R units. And we're just going to connect over and down and up here and over. And you're going to get kind of another box on the side. And this box is going to have dimensions R, 3, and 1. So it's going to be 1 times 3 times R. You're going to get a matching one on the other side that I'm not going to draw, which means we're probably going to have something like this. 2 times 3R plus And just for reasoning purposes, we'll come out here a distance of whatever r is. We'll come over here, we'll come up and over to the box and over this way. Now, this will also be r units away from the box this way off of this face, okay? So this one's going to be 4 times 1 times r. So it's going to be 4r, and you're going to get one on the other side, which is why we double it. Then there'll be one of these regions on top. I'm just going to draw it so we can see some other stuff in a second. Come over here, onto here, come up. All right, and so you're going to have a box on top too that extends off of box B. This one's going to be 4 by 3 by r, so it's 12r. If I add this up, it's 7 plus 12 is 19 times 2 is 38r. So we get 38r. We're slowly building what the region is. Now, what else is there? There's also in between these two pieces that extend r units away, I can make a quarter circle, and that quarter circle can come all the way up. And since it goes straight up here, there'll be another one on the back side, another one over here, and another on that corner of the same exact size. And furthermore, if we put them all together, they're going to make a cylinder. And the volume of a cylinder is pi r squared h, of course. Now, we don't know what r is, and we don't really care, but h is just the height of the box here, which is 1. So we're going to get pi r squared plus. Okay, if I do that, then there'll also be one right here that comes down on this side and on this side. And this one's going to be r units this way, r units this way. It's again going to be this quarter circle on the base, quarter circle at the top. It's a quarter of a cylinder. And there'll be one here, one over here, one at the bottom, and one over there to again make a full cylinder. But this one's height is 3. We can quickly tell by reasoning there'll be another one here and here, which is going to be 4 pi r squared. Okay, if we add that up, you're going to get 8 pi r squared. We're really close now. We just need to figure out what's left. There's got to be some cubic thing. Here it is right here. If I look at r coming out here, here, and here, this is basically 1/8 of a circle right here. That is, r got a radius of, not a circle, a sphere, 1/8 of a sphere. And so if I take this 1/8, the 1/8 over here, one over here, one over here, and the ones on the bottom corners, it's a whole sphere. And a sphere is 4/3 pi r cubed. So now, what do we want? We want BC, which is the two middle terms, so 8 pi times 38 over 4/3 pi times 12. We just need to simplify now. 4/3 of 12 is 16. 8 goes into 16 twice, 2 into 38 19 times. Cancel the pi's, get B, win a prize.